This is the third video of Boxplot. It's highly recommended to watch the first and the second video before watch this video. Intuition of low adjacent value. We do the same. We order variable together with up interface and low interface from the highest to the lowest. Keep in mind, we order from the highest to the lowest. Lower adjacent value is the smallest observations, that is larger than or equal to lower interface. Lower outliers are observations that are smaller than lower adjacent values. Both lower adjacent value and lower outliers are observations from dataset. Let's go through some scenarios. I made also 5 scenarios, 1, 2, 3, 4, 5. To simplify the situation, let's assume there are a total of 30 observations in a dataset. Let's start with the first scenarios. In this case, lower interface is smaller than or equal to the smallest observation x30. In the whole dataset, x30 is the smallest observation that is greater than or equal to lower interface. Therefore, x30 is lower adjacent value, because no observations is smaller than lower adjacent value x30. Therefore, no lower outliers in these scenarios. Let's move on to the second scenarios. In this case, lower interface is larger than x30, but smaller than or equal to x29. In the whole dataset, x29 is the smallest observations that is larger than or equal to lower interface. Therefore, x29 is lower adjacent value. Because x30 is smaller than lower adjacent value x29, therefore x30 is a lower outlier in these scenarios. Let's move on to the third scenarios. In this case, lower interface is larger than x29, but smaller than or equal to x28. In the whole dataset, x28 is the smallest observation that is larger than or equal to the lower interface. Therefore, x28 is lower adjacent value. Because x30 and x29 are smaller than lower adjacent value x28. Therefore, x30 and x29 are lower outlier in these scenarios. Let's move on to the fourth scenarios. In this case, lower interface is larger than x29, but smaller than or equal to x27. In the whole dataset, x27 is the smallest observation that is larger than or equal to the lower interface. Therefore, x27 is a lower adjacent value. Because x30, x29, and x28 are smaller than the lower adjacent value x27. Therefore, x30, x29, and x28 are lower outliers in these scenarios. Let's move on to the last scenarios. In this case, low interface is larger than x27, but smaller than or equal to x26. In the whole dataset, x26 is the smallest observation that is larger than or equal to lower interface. Therefore, x26 is a lower adjacent value. Because x30, x29, x28, and x27 are smaller than the lower adjacent value x26. Therefore, x30, x29, x28, and x27 are lower outliers. This is an example of how to identify lower adjacent value and lower outliers. Mathematical definition of lower adjacent value. Lower adjacent value equal to xi such that xi larger or equal to lower interference and xi plus 1 less than lower interference. Let's go through some examples. Let's look at the first scenarios. In these scenarios, lower adjacent value equal to x30, therefore I equal to 30, x30 larger than or equal to lower interference, and I plus 1 equal to 31, x31 smaller than lower interference. Because x30 is the smallest observations, therefore x31 does not exist. Let's move on to the second scenario. Lower adjacent value equal to x29, I equal to 29, x29 larger than or equal to lower interference, and I plus 1 equal to 30, x30 smaller than lower interference. Third scenario, lower adjacent value equal to x28, I equal to 28, x28 larger than or equal to lower interference, and I plus 1 equal to 29, x29 smaller than lower interference. Scenario 4, lower adjacent value equal to x27, I equal to 27, x27 larger than or equal to lower interference, and I plus 1 equal to 28, x28 smaller than lower interference. The last scenarios, lower adjacent value equal to x26, therefore I equal to 26, x26 larger than or equal to lower interference, and I plus 1 equal to 27, x27 smaller than lower interference. This is a mathematical definition of lower adjacent value. This is the end of this video. Thanks for watching.